Okay, welcome to this video where we're going to learn how to solve a pair of equations simultaneously, where one of them is quadratic and the other is linear. Okay, now graphically this would typically look like this. We have a straight line that's crossing a curve, a quadratic curve, in two places. Okay, so we can see there are two places where the x and y coordinates of both equations coincide. Okay, so basically we're finding the two x values and the two y values of the crossing points. Now the first thing to do is to rearrange the linear equation, that's the one without the x squared, into the form y equals a function of x. So I'm just going to change this second equation. Okay, and I'm going to say that I'm going to add 3x to both sides. Okay, so just rearranging that, I'm going to have that 2y equals, I'll put it here, 2y equals 10 plus 3x. Okay, and therefore y is half of that, which is 5 plus, well, 3 over 2x is how we would normally write it, 1.5x. Okay, I'm just going to leave it like that for the moment, and I'm going to now go to the quadratic and replace the y with 5 plus 3 over 2x. Okay, because where the two graphs cross, both equations have the same y value and the same x value. So we replace the y with that. So I'm going to call this equation 1. Okay, and I'm going to say sub y equals 5 plus 3 over 2x into equation 1. Okay, and that's going to give me this. I'll put it under here. It's going to give me x squared plus 5x plus 3. Okay, that's equation 1, but instead of equaling y, I'm going to make it equal to 5 plus 3 over 2x. Okay, now the fraction is awkward. I'll just show you how we can deal with that straight away. And because we're solving the equations, we can do the same thing to both sides. So if you do end up with a fraction like that, the best thing is immediately just to, in this case, double everything. Okay, as long as you do everything to both sides, that's fine. So we've got 2x squared plus 10x plus 6 equaling 10 plus 3x. Okay, and now I take away the 10 and the 3x from the right, leaving 0. Okay, because we're going to solve a quadratic equation, so we need to make sure that the right hand side equals 0. Okay, so take away the 3x will give me 7x, and take away the 10 will give me minus 4 equals 0. All right, now what we should do at this point is try to factorize. Okay, if we can, we should. If we can't, then we can use the quadratic formula. Now this will factorize. If you look carefully at this, it's got to start with 2x and x in the brackets. Okay, like that, because that's the only way you're going to get the 2x squared. And the 4 at the end is either going to come from 1 and 4, one of them will have to be negative, or it's going to come from 2 and 2. But I think you can see that if you were to put a plus 4 here, okay, and a negative 1 here, that would give you the correct factorization. Yeah, because if you do 2x times x, you've got the 2x squared. The minus 1 times 4 will give you the minus 4. We knew that part. It was whether or not we would get the 7x. And in fact, we get 2x times 4 is 8x minus 1x is 7x. So that works. So that equals 0, and that gives me two values of x. Okay, to make this first bracket 0, x has to equal 1/2. Okay, and to make the second bracket 0, x has to equal -4. All right, so we get the two possible values of x. Now, of course, we're cheating slightly here because we can see on the graph that I've already drawn that the x values are -4 there, and that does look like it's a half for the x value. Okay, but you would solve these algebraically without the graphs. The graph is just confirming what we're doing, so you can compare and see. So how do we find the corresponding y values? Well, it's quite easy. We just take the two values of x in turn and substitute them into the linear equation in any of these forms, usually in this one, where it starts with y equals, because it's easier to substitute into there than it is to substitute into the quadratic. Okay, so you just do that. So we sub these into the linear. In fact, if I just call this here equation 2 here, okay, this one, sub into 2, okay, then I get that x equals 1/2. Okay, so I'm putting 1/2 into here. Y equals 5 plus 3/2 times 1/2, which is 5 plus 3/4. Okay, so it's 5 plus 3/4. Okay, and 3/4 is 3/4. Well, 5 3/4, which is equal to, well, I can either leave it as 5 3/4 or I can write it as 23/4. Okay, so that's a pair of solutions, you see, an x with its corresponding y, and then I do the other one, which is when x equals -4. Okay, y would be 5 plus 3/2 of -4. Okay, I'll just put that down like that, 3/2 of -4. Well, if you times -4 by 3/2, you get -12/2, which is -6. So that equals 5 minus 6, which is -1. Okay, so the four solutions are, there's the first x value, there's the first y value, there's the second x value, and there's the corresponding y value. And it also means that the coordinates of this point here are -4, -1, and the coordinates of this point here are 1/2 and 23/4. Okay, that's it.